The T section 150 mm by 120 mm by 20 mm is used as a strut of 4 meter long with hinged at both ends. So stop. Calculate the crippling load if Young's modulus of for the material be 200 GPa. Okay. So this one it is T section. Top flange it is given 150 by 20 mm and wave size it is given 100 by 20 mm. Okay. So wave size it will be this size it will be wave size. Okay. So overall depth of beam it is 120 mm and wave size it is 120 minus 20, it will be 100 mm. Okay. So first of all, we divide this section, it is in two parts. So wave size we consider this is first part and flange we consider this one it is second part. Okay. Flange size just we consider it is second part. Okay. First of all, write down the cross sectional of the wave size, that is A1 we called. A1 is equal to will be 100 into 20 mm. 100 into 20 mm. It will be how much? 100 into 20, it will be 100 into 20. It will be 2000 mm square. 2000 mm square. Then Y1. So this one it is measured from bottom side. Okay, from here. Okay. So just we draw the x-axis and y-axis. This one it is y-axis and this one it is x-axis. Okay, x-axis. This one it is x-axis and this one it is y-axis. So y1 it is measured from the x-axis. So it will be y1 it will be for we consider only for wave. Okay. So we think about only on wave side. So wave side depth it is total 100. So y1 it is 100 by 2. 100 by 2. So it will be 50 mm. 50 mm y1. Then A2. Now A2 we consider it is plane size. Plane size that is means section 2. This is section 2. Okay. Plane size it is 150 into 20 mm. 150 into 20. So 150 into 20 it will be 3000 mm square. 3000 mm square. 3000 mm square. Then next Y2 is equal to 100 plus 100 plus the total distance up to the wave it is 100 from the x-axis. 100 plus 20 by 2 plus 20 by 2 plus 20 by 2. It will be how much? 100 plus 20 by 2, 110 mm. 110 mm Y2. Okay. Then calculate Y bar, that is center of gravity. Y bar is equal to K1 into Y1 plus A2 into Y2 divided by A2 into Y2 divided by A1 plus A2 divided by A1 plus A2. A1 plus A2 is equal to Y bar it will be here. So A1 it is 2000 mm square and Y1 it is 50 mm plus A2 it is 3000 mm square. Then Y2 it is 110 divided by A1 plus A2 divided by A1 plus A2. A1 it is 2000 mm square. Then A2 it is 3000 mm square. 3000 mm square. So if we get Y bar is equal to 2000 into 50 plus 3000 into 110 divided by A1 into 2000 plus 3000 we will get 86 mm. So y bar is equal to 86 mm. Y bar is equal to 86 mm. I will note down this value. Y bar is equal to 86 mm. Okay. This is center of gravity about the x-axis. Okay. But x bar it is x bar how much here? X bar it is symmetrical about the y-axis. Still this one value it is not required, but just we will calculate x bar is equal to it is symmetrical about the y-axis. So it will be 150 by 2. 150 by 2. It will be 75 mm. 75 mm. 75 mm. 75 mm. Okay. Then next calculate the moment of inertia. Moment of inertia. Moment of inertia. Moment of inertia about moment of inertia. Moment of inertia about x-axis. About x-axis. About x-axis. About x-axis. Okay. So I-axis actually this about the x-axis it is unsymmetrical. So by law of parallel axis, I-axis is equal to I-axis is equal to x-axis is equal to summation of Ig h square. Summation of Ig h square. Summation of Ig plus ah square. Ah square. This is the law of parallel axis. Okay. Law of parallel axis. Okay. So now we need to calculate moment of inertia here. Y bar it is 86. Okay. So first section it is wave size. Okay. So axis is equal to BD cube by 12. So first of all, B it is here for wave size. B it is 20. B it is 20, and D it is wave size of D it is 100 cube. 100 cube divided by 12. 20 into 100 cube divided by 12 divided by 12 divided by 12 plus Ig it is for wave size it is area 100 into 20. It will be 2000. So h bar it is y bar minus y1 square. H bar it is y bar minus y1 square. Okay. Y bar minus y1 square. Y bar minus y1 square. Okay, this value. Okay, I will write down this value here. First of all, once again we will calculate. So Ix is equal to so wave size it is width it is 20 and depth it is 100 cube. 100 cube BD cube by 12 means 20 into 100 cube divided by 12 divided by 12 divided by 12. Then plus area it is A1 it is 20 into 100. 20 into 100. It will be 2000 into, so h1 square means y bar minus y1 square. So I will write on here means we will get idea about that. H1 is equal to y bar minus y1. Y bar minus y1. Okay. Y bar minus y1. So y bar it is how much? Y bar it is 86 mm. Y bar it is 86 mm. Y bar it is 86 mm minus y1 it is how much? Y1 it is 100 by 2, that is 50 mm. 100 by 2. So 86 minus 50, it will be 36 mm. 36 mm. Okay. So it will be get 36 h1 it is 36 square. 36 square. Okay. 36 square bracket square. 36 square. Then next plus 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 plus. Next it will be second section. D it is 150 into D it is 20 cube 20 cube 20 cube 20 cube divided by 12 divided by 12 divided by 12, then plus plus 8 square. Area of this plane size it is 150 into 150 into 20. It will be 3000 into y bar minus y2. So x2 it will be, so now x2 is equal to y bar minus y2, y bar minus y2, y bar minus y2. Okay, y bar minus y2. So y bar it will be 86 minus y2 it will be 100 plus means 110. It will be 110. We will get 86 minus 110. We will get minus 24. Minus 24. Okay. So h1 square in bracket minus 24 square. If you done square, then all the negative value will be converted into positive. Okay. We can write here also 24 square. Okay. Write on axis is equal to write on axis is equal to, so first term 20 into 1000 cube, sorry 20 into 100 cube, 20 into 100 cube divided by 12 plus 2000 into 36 square, 1000 into 36 square. So this one first value with 4.2586 into 10 raised to the power 6 plus second one it is 150 into 20 cube divided by 12, then plus 3000 into 24 square. So second it will be 1.828 into 10 raised to the power 6, 10 raised to the power 6. Okay. So total it will be axis is equal to 1.28 4.2586 into 10 raised to the power 6 plus 1.828 into 10 raised to the power 6. It will be get 6.08 6.0866 into 10 raised to the power 6 into 10 raised to the power 6 mm raised to 4 mm raised to 4 mm raised to 4 mm raised to 4. This one it is moment of inertia about axis. Okay. Then same find out moment of inertia Iyy. So Iyy it is symmetrical about the Iyy axis. This T section it is symmetrical about the Iyy axis. Okay. So that's why we don't require to apply the law of parallel axis. Okay. So Iyy is equal to BD cube dB cube by 12. D it is dB cube by 12. So first D it is 100 into B it is 20 cube. 100 into 20 cube divided by 12. 100 into 20 cube divided by 12. Divided by 12. Then plus, we apply law of parallelogram here also, but it is not y bar minus x bar minus x1. So x bar and x1 it will be same axis. That's why we don't require to apply the law of parallelogram here. Okay. Sorry, law of parallel axis. Okay. Then second one it is 20 into 150 cube divided by 12. 150 cube divided by 150 cube. 150 cube divided by 12. Divided by 12. Divided by 12. Okay. So we get IYY. IYY is equal to 100 into 20 cap 3 divided by 12 plus 20 into 150 cap 3 divided by 12. It will be 5.691 into the 10 raised to the power 10 raised to the power 6 10 raised to the power 6 mm raised to 4 mm raised to 4. Okay, this one it is IXX and this one it is IYY. Okay, so which value it is less, that we will take IY I for. Okay, so IYY is less than IXX. So IYY is equal to I. IYY is equal to I. Okay, IYY is equal to I. Okay. The next one, it is what it is given. Length of column it is given 4 meter. L is equal to 4 meter. L is equal to 4 meter. Okay. So boundary end condition it is given, both the ends hinged. End condition. Both ends hinged. Both ends hinged. Both ends hinged. So when both ends is hinged, the effective length LE is equal to L. LE is equal to L. LE is equal to L. So L it is 4 meter. 4 meter. Convert it is in mm. That is 4,000 mm. 4,000 mm. Okay. 4,000 mm. Then modulus of elasticity it is given. E is equal to 200 gigapascal. 200 GPa. 200 gigapascal. To convert it is in Newton per mm square. 200 into 10 raised to 3. 200 into 10 raised to the power 3 Newton per mm square. Newton per mm square. Then apply Euler's crippling load. So Euler's crippling load it is Euler's crippling load. Euler's crippling load is equal to pi square is equal to pi square into pi square into EI pi square into EI divided by LE square divided by LE square divided by LE square divided by LE square divided by LE square. Okay. So is equal to, put all these values here, pi square into E it is 200 into 10 raised to the power 3 Newton per mm square. Then I it is 5.691 into the 10 raised to the power 6 mm 4 divided by LE square. That is L it is 4 meter. It is converted it in mm. It is 4,000 mm square. 4,000 mm square. 4,000 square. So we get Euler's crippling load. Euler's crippling load is equal to pi square into 200 into 10 to the power 3 into 5.691 into 10 to the power 6 divided by 4000 square. 4000 square. It will be 702 point 702.098 into the 10 to the power 10 to the power 3 in Newton. Okay, in Newton. Convert it in Euler's crippling load. Convert it in kilonewton. Euler's crippling load. Convert it in kilonewton. So kilonewton it is 702.098 kilonewton. 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 So this one it is Euler's crippling load for T section. Okay.